We want to thank you guys for coming today. And Mike McNair is with Bell now. It used to be Bell Helicopter, and they recently changed their name. And he actually was the plenary speaker here last year and talked about the Uber Elevate program. And it's evolved, and a lot of changes have happened since that time, so he's going to be joining us here in a moment. So with that, let me turn it over to Mike.
Great. Thank you very much, Ed.
Sure.
So, it's, pardon the notes, there's lots of good stuff that I'm wanting to impart, so I want to make sure I get a lot of that across. But I'm definitely open to questions and discussion afterwards, so if you have some things that you want to follow up with, please see them. So Bell's way forward on-demand mobility. You know, on-demand mobility means a lot of things to a lot of different people, right? And it takes on different forms as well. There are some things that we're very familiar with already in today's world. We're familiar with Uber and Lyft kind of services, right? And that's an example of on-demand mobility. It's ground transportation. We're able to make use of it. A lot of cities are looking at on-demand mobility in the form of bicycles, and being able to check those out and use those for getting around a city area. But when it comes to something like an air option of on-demand mobility, that's I don't want to say it's new, but it's exciting and it's right on the edge. So that's what I'm going to talk about today, and that's what I'm going to spend some time covering. So imagine this: what if you had the option for applying on-demand mobility up in the air? What would that look like? So for instance, what if you had the option to travel more on your schedule and less on someone else's? If you needed to get from point A to point B across the Dallas-Fort Worth MetroCon, let's say you landed at Dallas-Fort Worth Airport and you need to get to Frisco. I don't know about you, but I've traveled that route with my car. That's a painful route. It's easy to take about an hour to an hour and a half, depending on the day and traffic. But what if you could bypass that? What's the value of your time? What's the value of your mental state when you actually arrive? Right? You're not dealing with that traffic. But what if you could transport goods from, again, point A to point B? And there's already a good amount of work going on with that. You have a number of companies. You have the Amazons, you have UPS, you have Domino's Pizza, you have all sorts of companies that are exploring drone delivery of goods. So Bell, it's looking at the space of being able to drop off someone's ordered pair of tennis shoes, right, on your doorstep. That's not sort of what we're looking at. We're looking at something larger. What if you could move goods on a business back-end to back-end kind of scale? What if you could move goods from a distribution center to a distribution center to a store? Think of it in that scale. So now you're moving things that might sit on pallets, right? You're moving large containers. So what does that look like? But what if you were a customer at Best Buy? I'll just use that as an example. And for all the lawyers, I'm not endorsing anybody. But what if you're a customer there and you said, I need a refrigerator, and it wasn't at that store. I want to go home with it today. But it existed at another location across town. What would it take for you to get that refrigerator to your house? You'd have to drive to the other location, pick it up, find your pickup truck, load it up and go. While that might be out of the way, it's costing you extra time, it's extra effort. But what if, back end to back end, store to store, that refrigerator could be shipped across town over the air and brought to your store location? You load it up in your truck, half an hour, you're good to go. Interesting possibility. So now things become more dictated on your schedule instead of someone else's schedule. It's more availability tailored to you than to someone else. So let's look at this. So on-demand mobility, when you really start to dissect it, and this is a good bit of the presentation, is really some of the things that we're learning at Bell as we drill down into on-demand mobility, and especially air on-demand mobility. There has to be a set of multimodal options available to the user. Think about that. We use this routinely. If you want to get on the TRE and go from Fort Worth to Dallas. You drive your car to the station, you get on the train, you get over there, you get to Dallas, you might get on to DART, and you get to where you want to go. It's multimodal. Adding on an air component adds to that infrastructure, adds to that overall system. Mobility is both a commodity and a service. A lot of folks think of it as more of a service, right? But being able to be mobile is something that you can sell. Think about that. It's something you can sell. There's a tangible component to this. It's driven by the need for choice. I don't know about you, but what time of day I want to travel and how I want to travel is unique to me. How you want to travel is unique to you, right? You might want to travel with your cup of coffee and your laptop sitting there with you. Someone else might want to travel with their book. Someone else might just want to stare out the window. Someone else might want to check email. But whatever you want to do during your travel experience is unique to you. But all this is enabled through a variety of technologies. It's real easy to think of air on-demand mobility as the air vehicle. But it is really so much more than that. It brings in a number of technologies, and this is just a small list of the technologies. Small list of those who are involved in the whole thing. Whether it's big data, smart cities, we'll hear about that, Internet of Things, right? Connected vehicles. We're experiencing a number of things on this list already with cars. And we're fully expecting a lot of those technologies to extend into the air vehicle world. Some things will have to be changed, right? Let me give you an example. When it comes to technologies that are being developed for driverless cars basically operate in a two-dimensional world, right? They don't fly, they don't jump. So air vehicles, they do operate in a three-dimensional world. So what does that imply for being able to be mobile? Driverless cars tend to go slower than most air vehicles. In order to stay in flight, you've got to have some airflow. You've got to move. When it comes to air vehicles, if you need to just stop, if there's an emergency situation, then just stop. On the ground with a car, you just pull into the next available curb space. Right? If you have to, you just push the big red panic button on the dashboard and everything just stops and you just stop in place. How do you do that with an air vehicle? At some point, you're chewing up energy, you're using energy. At some point, you have to decide where you're going to go. Because otherwise, gravity will decide for you. Right? So the decision has to get made. So there's some key differences, and those have to be extended from cars into air. And we already talked about being able to integrate with other transportation options. It's truly multimodal. So several years ago, NASA actually started out on this whole idea of on-demand mobility. So they started looking at the San Francisco Bay Area. They did a good amount of research, and they identified a number of reasons why air on-demand mobility is a good thing. They published their reports, and you can see the dates there in 2015 and 2017. They've got other reports that have come out, and they did a lot of fantastic work on this. And it's more than just looking at traffic patterns. It's just more than traffic congestion. They looked at the time saved. They looked at what would the benefits be on wear and tear of the roadways? What would the benefits be in terms of air pollution, noise pollution? What are the benefits? And the results kept coming back very positive. This is a potential direction to move in. Soon thereafter, Uber published their Elevate paper. And Uber came along and they said, look, we need to leverage some of what NASA has learned. And so Uber started putting together their Elevate concept, their Uber Elevate framework, and moved that along and helped that to go forward. And what's happened as a result, a number of suppliers, a number of OEMs, a number of contractors, they've all said, here's how I can contribute into that framework. What's interesting about the business area is Uber's framework, Uber Elevate, that's not the only framework out there on the streets. There are other frameworks. There are other manufacturers and OEMs that have proposed their own frameworks for doing exactly the same thing. So the business area itself has sort of blossomed a bit. And it's exciting to see that. It's exciting to see these OEMs take part. It's interesting to see how they are seeing themselves a part of this overall system. So let's take a look at the system. You know, Bell has a history of making aircraft. It's very easy to, when people think of Bell, to think helicopters. I'll put in one little parenthetical plug here. The aircraft that Chuck Yeager flew and broke the sound barrier with, that was actually a Bell aircraft. Oh yeah, that's right, that was a Bell fixed-wing aircraft. The jetpack, personal jetpack, that was a Bell invention. So Bell isn't just about helicopters. That's actually one of the reasons why we changed our name. We moved from Bell Helicopter to just Bell. Because we really wanted to accentuate and really call out that whole idea that Bell is all about flight. Okay? So within Bell, we've had this paradigm shift. We've had this realization that we have to think beyond just the aircraft. We have to think beyond just the vehicle. We have to realize there's more to this on-demand mobility picture than just the platform. It's easy to get centered on the platform. That's where a lot of the fun is, right? You get to see it fly overhead. You get to see it do stuff if you're into aerospace and aeromechanics and your flight controls and all those neat technologies. It's easy to get centered on the platform, but really, there's a lot more to it than that. So let's take a look. So you have the aircraft. That has to be able to do automated takeoff and landing. It has to have sense and avoid. It has to have all sorts of capabilities on it. Think about just the contingency operations that have to be built on board to an aircraft. Things that a human pilot has to work with routinely. What happens if the little light starts blinking on the dashboard? Right? What happens if you're starting to run low on fuel? What happens if, and you can go through the whole list of ifs. Well, if we're talking about an autonomous vehicle, all those conditions have to be allowed. What if you're a human pilot and you lose radio communication with the tower? What do? Right? You coordinate as best you can, you stick to plan, you fly safer, you become more aware. What if you don't have a human pilot doing the flying? And you've lost communication with your infrastructure? What do you do now? That's part of the question. What if you're being guided by GPS? What if that's being spoofed? What if you lost it? Lost a good solid link? What do you do then? Okay. So a human pilot, they would come along and say, well, I'm just going to look down at the ground and I recognize that highway over here and I recognize that river over there and I can get a general sense of where I'm at. And you navigate by landmark. What does that mean for an autonomous vehicle? There are techniques of visual navigation, but those still need to be matured. You have to work with other aircraft. There are other aircraft in this airspace. It's interesting to me how a number of people talk about one day all aircraft, that there won't be any aircraft with pilots on board. Okay, think about this. How many people like to just go take a drive in their car? They just enjoy the thrill of getting out in the countryside and just go take a drive. Is that going to keep you from giving up your driver's license? Right? You know, we talk about driverless cars, you're going to get all the drivers off the road. Well, there's still some people who really like to drive. What are you going to do about them? There's still pilots who actually just like to fly. What are you going to do about them? So to make the world that black and white, that distinct, is sort of a misnomer. Very potential. So we have to be cautious of that. We have a number of things that go on the ground that have to work within this overall ecosystem. You have ground operations for the vertiport and heliport. That means you've got to have fuel showing up. You have to have charging facilities. Within the Uber Elevate framework and with others, if we're making use of the top level of, let's say, a parking garage for a vertiport, what does it mean to be able to pump fuel up to the top of that parking garage? You now have to have fire suppression equipment. You have to have pumps to get stuff up there. What do you do if there's a spill? If they have hazmat procedures? Right? We have to sort of think this process through. How do you get high voltage charging stations up on top of a parking garage? What does that mean? What's involved with it? Think about this. If you use the top of a building, top of a parking garage, you have an air taxi that lands on top of it, and it needs some amount of repair. It's not currently flyable. How do you get it off the top of the parking garage? Right, you see where I'm headed with this. There are real solid, practical things that have to be thought through in order to make this all happen. Flight services, again, similar thing. We have ADS-B, GPS, we have weather, we've got all sorts of mapping services. All those have to be adapted for autonomous flight. We understand how those work for human pilots and how they consume that information. We have to think about how that information is consumed by an autonomous platform. Flight operations, how do you move from point A to point B in our national airspace? Pilots have to file flight plans. Autonomous vehicles might just have to as well. The airspace has to stay organized. I spoke with an FAA representative a number of years ago, and I asked him, so what, if you were to say for FAA, what are the 3 top priorities of the FAA? He said, oh, that's simple. I said, okay, what are the 3 priorities? I was there with my notebook, I was ready to write it down. He said, safety, okay, I got that. Safety, and safety.
Not getting your bags there on time?
Well, that's a whole different thing. And then fleet operations, right? On the ground world, we're very familiar with that. We understand operations of moving 18-wheelers around. We understand supply trucks. We understand how to get things around. We understand what logistics means on the ground. But what does this mean for moving passengers and moving cargo through the air in an urban environment? It's a paradigm shift. It's a whole new system. And it's more than just an extension of the current system. One thing that's rapidly emerging, and we're seeing a lot of activity with, has to do with standards. I'm not going to go through everything on here. There's plenty to read on there. But what I really want to point out with this is that standards work is really a cooperative effort between the needs that industry has, the actual execution that projects have to perform. What are the operational requirements to actually have this stuff work in real life? And the operating environment, and being able to specify what are the envelopes and what are the limitations and constraints of that operation. We have to be able to specify all that. We understand that actually really well when it comes to automobiles. Right? We've got posted speed limit signs, we have yield signs, we've got traffic lights, we have rules of the road, we have rights of way. Right? We all understand that when you come to a 4-way stop, you're supposed to let the person, not the first person who arrives, right? Or the first person who moves through the first. There's actually a law, there's actually a rule that says, here's how you move around the intersection. Right? Whether it's used in practice or not is a separate thing. Okay? I am a practical driver. Okay, so we have to understand that operating environment. And we have to understand the rules of that operating environment for aircraft. And we're talking about aircraft that are flying, let's say maybe in the 1,000 to 2,000 foot range above the ground. So we're not talking something that's up too high. And generally, most of this aircraft will be above buildings. But we have to understand what that airspace is going to look like. We have to understand how that's going to be managed. And what a lot of folks don't realize is in order to get to that air taxi kind of airspace, you have to fly through a whole bunch of airspace already to get there and to come back down. That means you're flying around with drone operators, you're flying with real estate developers who are using their drones, you're flying around with rail inspection, bridge inspection, you're flying with hobbyists just to get through that. You're flying with general aviation, again, to get through those lower altitudes. So all that has to be coordinated, all of that has to be figured out. Plenty of room for standards work. And then one of the most overlooked areas has to do with users. And for this track, I think that's really important. That's sort of where the IoT angle, in my mind, really starts to come into play. You know, with, it's really, we have to spend our time, I'll say it's sort of traditional systems engineering, right? We have to spend the time to understand where are the people involved and what are their roles. What are they doing in each step of this process? It might be the user experience of a person on the aircraft. It might be someone who's handling vehicle monitoring and control. It might be someone who's handling asset management and maintenance and repair. Maybe it's a person who's handling air traffic and they're performing sensing and monitoring and management of the airspace. Maybe it's someone at one of the vertiports. They're handling refueling and maintenance. Maybe it's a person over here handling scheduling and embarkation, debarkation. Now think about this. Where are the opportunities on each of these roles to make use of some new technology? Not just make use of the technology, but to integrate that technology into other things. One of the things we really want to be able to do is turn this entire air taxi experience into a seamless experience, right? The folks that were talking earlier, being able to use something like an app and being able to pay bills and to look at what's going on under the ground and all the neat things. That kind of integration is important. But we want to have that kind of integration to include actually moving people around too. Imagine if you're here at Hearst Convention Center, right? And you get towards the end of the workday and it's time to go home. What would this world look like? And I want you to envision this. What would this world look like if you went to the top of the parking garage over here? And we all queued up. We had our apps out. Said, all right, I'm ready for my air taxi. Come get me. I'm ready to go home. Or the rest of my workday is calling. I need to get back to work for a few minutes. Right? What would that picture look like in your mind? What are the IoT kinds of things needed to make just that happen?
You have to have flight plans for every one of those flights.
You have to have flight plans, yeah. And it's amazing what has to happen to pull this together. When I'm going to get a little bit on the technical side, and this is more just to help round it out a little bit. But when it comes to autonomous operations, we have to understand this architecture picture. We have to understand what is it going to take from a technical perspective to really make this happen. When it comes to most air vehicle manufacturers, we're really familiar with those dark portions of those boxes up there. We're really familiar with aircraft systems. We really understand how to make a move. We understand some of the sensing and communications that's on board. We understand how to command them, how to control them. What's new for a lot of these OEMs is being able to come along and say, I've got to control it now, assuming I don't have a person on board. What additional sensing do I need? What additional communications do I need? How do I tie this aircraft into existing ground operations, existing infrastructure? I need to be able to come along and make use of some technologies that give me autonomy and autonomous behaviors. How do those tie in? Basically it's a move from being teleoperated, something like what we're familiar with drones. You sit there with your little controller pad and you're moving things around, you've got arrow keys or a joystick or something, right? And you fly this aircraft around. To be remotely piloted, to optionally piloted, to non-piloted. Those are big steps. It's really easy to talk about getting to non-piloted in a single breath. But there's a lot of technology advance that has to occur to really make that happen, and to do it safely. There are a lot of technology focus areas. These are some of the areas that I'm personally involved with. And these are some of the areas that I lead at Bell, being part of our innovation area. So I get to enjoy a lot of this leading edge stuff. But all this eventually feeds back into autonomous operations. How am I doing on time?
You got 25 minutes? Okay.
I'm going to spend just a few minutes talking about qualifying and certifying an aircraft system. When it comes to a lot of the folks that you'll see, there are a number of companies that You can go onto YouTube, you can pull up a video, and they'll show you some neat footage of aircraft and aircraft designs flying around and doing neat stuff. How many of them are certified? Right? I mean, they've actually gone through an FAA certification process. They're DO-254, they're DO-178, they're making use of SC-228 MOPS, they're all the things that have to be in place. They're complying with Part 23 or Part 25, right? How do you make that happen? The road to certification is a challenging one because the regulations that exist right now have been geared towards piloted human-flown aircraft. So now that we're bringing in non-human flown aircraft, what does that mean? There's a distinction here between qualifying and certifying. Qualifying means that something meets its requirements. And in a very real sense, something that's certified means that it's meeting its expectations. One of the key differences between qualified and certified is qualified says, yes, this is a laser plane. Okay, I'll use this as an example. Certified means that a separate authority has come along and said, yep, that's a laser pointer and it conforms to these standards. It's got someone else's stamp of approval on it. Okay, make sense? So something can be qualified, but not certified. There has to be a separate authority that certifies. And that's the trick. A lot of folks, they'll come along and they'll say, we've got something that has requirements and meets requirements, but whether it's certified or not is a separate thing.
So in general IoT, there are, we have to call for standards. And of course, there are, 15, 18 standards bodies looking at IoT applications and standards, right? In IoT standards and autonomous flight standards, how many bodies are actually looking at the standards for autonomous flight?
You have actually done a great job of leading into the next slide.
I'm available for bandwidth.
So let me hold off on that just for a second.
Okay.
All right. Number of standards that already exist. When it comes to this though, when we're talking autonomous systems, we're also talking about non-deterministic systems. And so what does that mean? How do you certify a non-deterministic system? Something that's adapting as it goes. Let me ask you a question, and I've run this by a number of folks as well. FAA folks, NASA folks, EASA folks, the European equivalent. And ask them, how do we certify, how do we license human pilots? They're constantly learning, they're constantly adapting, yet we still allow them to fly these machines. Right? What's the difference? Give that some thought. I'll come back to that in just a minute. All right, so some challenges. So good standards, they really have to rely on good practices and what's real. It's really easy to come up with a standard and that no one uses. But we really need effective standards. The business area is moving too fast to not have good, effective standards. And we specifically need standards for autonomous air vehicles. And there's some real questions that come with that. What do we do with open source software? How do we certify open source software? Something that's developed by community, how do you get that through an FAA certification process? No one really understands how to do that because who controls it? Right? Who owns you understand ownership from licensing, but who's managing the version updates? Who's managing testing it and making sure it's performing as expected? Non-determinism. We live in a world of multi-core processors. We've got artificial intelligence, machine learning, we've got machine vision, we've got all sorts of things to help us as a toolbox. But it leads to very non-deterministic solutions. We have tremendous technology growth. It's amazing to see what's going on right now. It used to be that I could go off and buy a LiDAR. This fits in a box like this. There are solid state LiDARs that fit on a ship like that now. It's amazing what's out there. And the technology change is rapid. It is tremendously rapid. What we write regulations for and standards for now are very likely to be out of date within a year or two at most. That is the case. Trust. When it comes to autonomous vehicles, how do you trust what they do? What does that mean to us? Self-preservation. Think about this. When we hop on an aircraft, we hop on an airline, and we're flying from here to somewhere else, we assume that everything's going to be generally okay. We assume that all the flight crew, they're doing their job, the ground maintenance crew, they're doing their job. We're assuming that all that's going to work together. And we're assuming that in the event that something bad happens, if nothing else, the pilot up front values their life enough, and this is going to sound blunt, that they value their life enough that they're going to protect themselves. Because I'm sitting a few rows back from them, I'm going to be okay.
Wasn't there a noted case where a German pilot committed suicide by flying into the side of a mountain years ago?
Yes. But there's the general assumption, right?
Right.
Okay, so to your question just a moment ago, Pete. So ANSI started their UAS standardization collaborative. What they realized was that RTCA, SAE, IEEE, and others, and there's about a dozen different standards organizations, each with a whole host of standards committees, had started off and have been working for years on their own UAV standards. And they put together this compendium of all those standards. And what they did was they identified here are the gaps, here are the overlaps, with all the intent of throwing that back out to the standards groups to say, y'all need to fix this. Here are some areas that we need new standards. And here are some areas where RTCA and IEEE and SAE, they overlap. So when it comes to certifying an aircraft, which standard do you choose? Which standard is going to matter to FAA? Right? It's a tough question. So ANSI, it was great that they pulled that together. So all those different standards organizations, they came together for a year. They recently published that report, so it's out there. If you follow the link there, you'll get to the report. Okay? Terminology. Now I'm going to start picking up the pace a little bit because I think I'm a little bit behind. So terminology, it's important to understand that there's distinctions between automation, autonomy, and intelligence. They're on a scale. Just like there are differences between qualification and certification as compared to something like licensing. You need to understand that. Remember, there's a person in the loop, there's a machine in the loop, and what we've done is we've put the machine in place of where we're used to putting a pilot. There's practices, there's standards, there's regulation and law, and we have to understand those distinctions and be able to apply those when it comes to air platforms. There are some additional key distinctions that we've picked up as we're going through this process at Bell. I want to make sure that that's clear as well. On the left side, this is sort of a quick stack of what we're used to with aircraft. We've got the aircraft itself, we've got this layer of flight controls, controls all the control surfaces, the flaps, the motors, the propulsion, landing gear, all that kind of stuff. And right above that, you have a human pilot who's controlling it all, who's monitoring what's going on. On the right side, that's the autonomous air vehicle. Starts to look sort of the same. You've got the aircraft, you've got flight controls, but now you have this box sitting there. This autonomy and automation box. And it's doing all sorts of stuff. So what does this look like? How does this differ? So there are a couple of ways to look at it, a couple of variations to it. When you compare the human side to the machine side, there's a difference in awareness. If it's a human pilot, they know what they're doing. You know, they know, okay, yeah, I'm a good mental, faculties for the day. I'm aware of what's going on. I can talk to other pilots. I can talk to the ground control. I can move forward. When it comes to the aircraft side, the autonomous aircraft side, that's a reliance on onboard sensing that's coming up from the ground, reports, not necessarily other pilots directly, but reports coming from other pilots and reports coming from other aircraft on how well they are doing. Might look at it, the differences in terms of control. A human pilot is going to rely on their experience, their training, their intuition. But on the machine side, there's a bunch of rules, there's data that has to be processed, there's algorithms that have to be proven. right? We have to understand those distinctions. And it actually, as you work through this list, it actually gets to be a little blurrier as you go. When it comes to experience, you can look at a person and say, this person has a certain number of flight hours, they've gone through a certain amount of instruction, they've logged, you can look at their logbook and say, well, these are the kinds of flights this pilot has gone through. On the autonomous side, what does that mean? What does experience mean to an autonomous vehicle? You can look at flight hours, but that just tells you wear and tear. Right? So what's the equivalent of an experience base? It could be what kind of testing was done on it. It could be a defect count. It could be something, but we're still wrestling with what does it mean to say this autonomous aircraft is an experienced piece of autonomy, right? It's sort of hard to talk about because we really don't know what we're talking about quite yet. And then in terms of commitment, I mentioned this earlier, from a human side, they're committed to a flight. Right? Generally, the pilot wants to get to the destination just as much as you do. Right? You rely on the integrity of that pilot. On the other side, what does commitment mean to a machine? Right? We rely on that. It's a very intangible thing, but we rely on it. Do we have to monitor, do we have humans that monitor the machine? Maybe. But we have to think this through. So we have to figure out what does proficiency mean? And one of the key questions is in case something goes wrong. When it comes to having people in the loop, we generally have someone to ask a question of, why did you choose that? Why did you do this? We can interview people after the fact. What was in your mind when this happened? When it comes to a machine, what does that interview process look like? You can go look at log files, you can go look at collected data. And that'll give you raw information. But for a non-deterministic system, who do you ask about how that data was used and interpreted to make the decision that was chosen? It's a tough one. It's a tough question. Bell also recently won a contract from NASA, their Systems Integration Operations contract. This is just a top-level picture. It gives an idea of sort of how complex this world is. The contract itself is really focused on command and control and detect and avoid. But this is making use of air-to-air detection as well as ground-to-air detection. Fun little picture to think about. It includes bringing in weather effects and what effect that has on flight as well. In addition to just regular line-of-sight RF, satellite communications, you name it, whatever the options happen to be. When it comes to certification, there's a tremendous regulatory structure. One of the main purposes of the NASA SIO effort is to help chart out what does that certification effort look like. That is tremendously important to build. All of our aircraft have to get to a point where they're certifiable. We have to get to we have to get through that process and understand that process. We have to also understand that all systems interact with each other. A lot of that's through a detect and avoid, that's also through command and control. Those are fundamental. You have to have both of those technologies in place in order to be able to fly in any amount of autonomous operation. So there's some key challenges. Lots of words on these charts. I'm just going to leave them up there. The presentation is being videoed, so you can look at it that way. And presentations, I think, will be posted.
Yeah.
So you can look at the slides that way. Right. But when it comes to technology challenges, this is just a short list. If you're into research, if you're looking for something to do to help move this along, look at that list. Pick something on. We could use your help. As an industry, we could use your help. When it comes to technical challenges, same thing. There's a lot of work out there. Again, it's more than just develop the aircraft. It's a bigger picture. Challenges with people. Think about this. This is one of the stressing cases I pose to my team. If there's, if you think about you're on a train and you notice something's not right, what options do you have as a passenger to affect the motion of that train? Pull the little string. Yeah, you can go find a representative on the train and say, help. Why is the train going faster than I would have expected? Right? But what do you do about adverse conditions on board something like an air taxi? Who do you call? And what can they do about it? Remember, when it comes to an autonomous air taxi, the only people you have on board are unlicensed, untrained passengers. Let that sink in for a moment. It's, in a sense, it's sort of like letting a child drive your car to school. What would you do to that car to get your child to school safely? That's sort of what we have to think about. You have unlicensed, untrained passengers. And then regulatory and legal challenges. We've got to figure that out. So some final thoughts, and then a quick video, and then I'll be off the stage. So some quick takeaways. On-demand mobility is more than just the aircraft. It's more than just GNC. So it's more than just navigation. It's more than sensing. It's really a multi and interdisciplinary effort. You really have to wrap your brain around that to really be successful in this space. It's more than the aircraft. Second one, it's a rapidly developing solution requires coordination. And what that means is one company is not going to do it alone. There have to be some really good strategic and tactical partnerships to pull this off. I can tell you right now, Bell is not a sensor provider. When people think of Bell, they don't think of, oh wow, they make great GPS receivers. Right, that's not what you think about. So we have to partner with folks that make really good LiDARs. We have to partner with people that make really good GPS receivers. People that have really good GPS INS units. We have to partner with those. But we have to understand those relationships and make those relationships work. We have to leverage existing and emerging technology, but because the industry is moving so rapidly, we have to be willing and able to innovate. We have to be ready and willing to adapt. If you're in the industry, especially in the sensing part of the industry, you've seen sensors shrink, you've seen them get more capable, and that's just over the last year. It's very rapidly changing. We have to adapt to that. Certification for UAS is a brand new path. We're just now beginning to understand parts of it. But at the same time, we want to get up in the air and fly, so we're trying to rapidly move that along. So we have to work it often, we have to work it early, work with the authorities so that they move along with us so it's not a big surprise at the end. And think about this, what we end up with has to be safe enough for you to fly, and I want to make this distinction. As engineers, as scientists, as people who are technology oriented, we might enjoy the thrill of getting into this brand new air taxi and say, yeah, take me on a test drive, right? That'd be fantastic. But what would it really take for you to say, oh, and by the way, tomorrow I want to put my third grader in that air taxi. I want you to take my third grader to school. All of a sudden the picture may have changed. Get the idea? So make it safe enough for you to fly in, but make sure it's safe enough for your loved ones. Ensure it. Not just make it safe enough, but ensure it somehow. Make it that safe. Okay? So I'm going to throw out one quick video. This is a concept video that Bell put together. We unveiled it earlier in the year to give an idea of what that user experience might be like with an air taxi. So think about these different scenarios. If you're in the IoT world, where would IoT apply? If you're in sensing, where would sensing apply? See all the traffic along the bottom of the street. Imagine that user experience there. So let me throw in one last thing. Because this is such a rapidly evolving area, and this is a quick shameless kind of plug, I guess. So we are actively hiring for a number of positions. So if you're interested in something like this, go check out our website. Okay? When it comes to flight controls, when it comes to human-machine collaboration, when it comes to autonomous behaviors, in these kinds of applications, we are all over it, and we're looking for experts. We're looking for people who want to contribute into this. So I'd encourage you to go take a look. We've got a number of job openings there. Feel free to apply as you feel like you're qualified. All right, well, that's it. I appreciate the time. I think I've got 2
Yes.
minutes.
Yeah. Any questions, guys?
From anyone other than Pete.
Hey. You know, you have your shot at P10.
I got one.
Yeah.
It seems like there's a lot of things that are going to happen. I guess when it becomes operational, like what do you guys think the cost would be? Like how would it compare? I know the time it would save a lot, but how would for an average person using it, how much would it cost them? Have you guys thought about that?
Well, we've given some thought to it within Bell, and really probably a set of numbers to reference would be more of what Uber has published in their Elevate paper. And really, honestly, when it comes to operational cost, when it comes to the cost of a vertiport, how do you share that cost, and all those, people are still really trying to figure that out. So having a good, solid answer just doesn't exist right now. But I know that Uber has said that they really would like to push towards something like their Uber Black kind of costing. They want to come somewhere close to that. So we'll see what happens. Any other questions? Okay, great. I'll be here for a few minutes. If you have any other thoughts? Thank you.
All right, guys, let's give him a hand.